to this Transplant Systems presentation on soil media particle size distribution. Beltwise Gold soil media is the only mix in the tobacco greenhouse industry with all the right technology. The North Carolina Growers Guide states that you should consider a soil mix that has a wide range of particle size distribution. But what does that mean? This presentation will help you understand what it means for a soil mix to have a wide range of particle size distribution, and why it is important for the soil mix you use in a float system to have this attribute. To begin with, a wide range of particle size distribution simply means that the soil media has small, medium, and large particles. The particle size distribution of the soil mix determines the soil porosity and determines which plant you have. Soil porosity refers to the pore space between the soilless particles. It is the amount and the size of these pore spaces that determines the water holding capacity and the air porosity of the media. Therefore, it can be said that the water holding capacity and the air porosity of a soilless mix is impacted directly by the particle size distribution of the mix. My experience has been that once growers are informed about this fact, they begin to understand the difference in soilless mixes and why a coarse textured mix is the best soil mix for them. Water holding capacity and why it is important. Water holding capacity is the ability of the soilless media to hold water. Water holding capacity takes on a different meaning or importance in the float system versus an overhead irrigation system. Water holding capacity of the media in an overhead irrigation system affects the frequency of watering. However, in the float system, we're not concerned about the frequency of watering because the plants are sitting in water and have constant access to water. In a float system environment, water holding capacity is important, but for a different reason. In the float system, water holding capacity is important because of the impact that it has on air porosity. The difference in these two plant root balls is due to air porosity. Everything else is equal. To understand how water holding capacity can impact air porosity, we have to understand that water is held in a media is either available or unavailable. The amount of unavailable water in soilless media is quite high and is determined by the size of the components making up the mix. Remember this statement because this is key to understanding the difference in soil mixes. Unavailable water is held so tightly to the particle surface that roots cannot remove it and gravity cannot drain it. Small, fine texture media particles create small pores between particles. These small pores are referred to as capillary pore space. Capillary pore space holds water against gravity and contributes to higher water holding capacity. Here is where water holding capacity impacts air porosity. Remember, air porosity created the difference in these two plants. Air porosity is determined by the amount of non-capillary pore space. Non-capillary pore space is the larger pores between large particles of the media. Remember this because it is key to the differences in media. Small particles, fine texture, create higher water holding capacity with less air. Large particles, coarse texture, create lower water holding capacity with more air. Fine texture mix creates small pores where water is held against gravity. Coarse texture mix creates large pores where water drains by gravity. When water drains by gravity from the larger pores created by a coarse mix, air moves in. Small media particles in fine texture mix create pores that hold on to water, whereas the large media particles in a coarse texture mix allow water to drain. And when the water drains, air moves in, giving you higher air porosity. Higher air porosity promotes healthier roots like the one on the left. A mix that has a wide range of particle size distribution has sufficient large particles to allow water to drain and air to move in. Whereas a mix that does not have a wide range of particle size distribution, does not have larger particles, and its small particles contribute to higher water holding and low air porosity. Coarse texture mixes are well structured, whereas a fine texture mix is poorly structured. Therefore, the water holding capacity of the media in a float system becomes extremely important, as it will have a direct impact on air porosity. It is the particle size distribution that determines the water holding capacity and subsequently determines the air porosity. A fine texture mix will therefore have a higher water holding capacity and a lower air porosity. A coarse texture mix will have a lower water holding capacity and a higher air porosity. The plant on the left is in a coarse mix, and the plant on the right is in a fine mix. Select a coarse textured mix with a wide range of particle size distribution will give you lower water holding capacity and a higher air porosity. There is one more factor influencing the soil's media ability to hold water. Water holding is also influenced by the surface area of the peat particle itself as it absorbs water. Fine texture media has a smaller particle size than coarse texture media. However, the sum total of the surface area of the fine texture media is much larger than the sum total surface area of a coarse texture media. Therefore, fine texture media will hold substantially more water than a coarse texture media will. The media best suited for a float system environment is one that has a broad particle size distribution. This media will be coarse in texture. Beltwise Gold Mix is a coarse textured mix with a wide range of particle size distribution, giving you lower water holding capacity and a higher air porosity, and yields a better root structure.